everything is hopelessly broken. It's all done. Like the end. See ya. Bye. Mic drop. This is an unscripted conversation, which we have no intro to. And this is it.
Life as a hacker with kids and a dog and raising a puppy.
With my career, oftentimes I'll go, okay, there's nothing new under the sun. What has someone else smarter than me done to accomplish this task, whether it's a hacking task or whatnot? There are professionals who have written books, many books, on how to successfully parent. And I don't read those books. And then also, like, your parents have told you, they raised you, and they're like, I am so much smarter than you. I've lived through this. My father called me an idiot for this thing, and I'm now calling you an idiot for this thing. And now I am going to tell it to my daughters, is you're an idiot for this thing. Again, in nicer language. But the cycle just repeats, and I feel like there's probably like a morsel of truth in that for like a career of like, there are smarter people than you, and it's okay to read what they say because you can avoid so many mistakes.
Well, it reminds me of there's a really famous song called the Sunscreen Song, and and a lot of people will probably know what I'm about to say, but there's this idea that advice is just this thing where we take the past, dust off our mistakes, and attempt to hand it to the next person as if we actually know what we're talking about. So I was going to say about the parenting books, I've read 3 different books on some form of dog psychology or dog raising. All 3 of those books have wildly different standpoints on how you should raise a dog. And now I'm working with 2 different sets, 2 different trainers, a puppy class and an actual private trainer. And even those 2 who, they're fully trained in how to train a dog, their similarities wildly different in many regards. And even that, I have some background. Like one of my best friend in the entire world used to be a vet tech, and he gives me advice all the time on various raising things. And he has the same breed of dog that I do, so he knows a lot of this specific breed psychology. And even he's just like, those trainers don't understand this particular breed. I've been raising them since I was a kid. You need to do this. You need to do that. And so it's like, I'm convinced that while, yes, it is important to go off and read those things, it's also important to realize that the reality of your moment, whatever you're dealing with, whether it's, a hacking challenge or some kind of hacking, thing or reverse engineering thing or raising a dog or raising a kid, whatever moment you are in, while someone may have experienced it before, the context within which they have experienced it, wildly different. Wildly different results. Maybe you both got to the end result that you were looking for, but the path you took to get there is going to be completely different, and it's going to paint your advice completely differently as a result. So as my old acting coach used to say, you're the trained professional, or you are receiving training, right? So take the advice of people that are coming in and filter it through all the training that you've gotten so far, and do your job, which is discard the things that you think are incorrect and attempt to do your best work moving forward. And I think that's the best piece of advice that I can give people in any situation.
Well, this ties into something which was like the purpose for having this conversation, which was at one point we had a stream and you're like, everything is broken all the time forever. The end. Abandoned computers returned to monkey. And it was like, it's one of my favorite rants you've ever gone on. And I think what was so interesting about it, though, and it falls into this, like your unique experiences are going to make you a unique snowflake, a unique person. Like, I hesitate to use that term, but I just love it. This is the unique snowflake. But what's interesting is there's so much to know in cybersecurity. Like, there are no experts in cybersecurity. And I'll use this as an example. What you do is wizardry to me. Like, I've said it to you, and you're like, this makes me uncomfortable. I'm like, you are a genius at virtualization technology.
I have to play that. I have to completely disagree with you, because I look out at my contemporaries and I see all the work that they're doing, and I see how far ahead they are in many intricacies of what they are doing and where they're going. But it's all hyper-focused on one particular technology that they're working on or one particular path that they're working on. So while I have to be exposed to a lot of what they're doing, and I say this, like, I'm not a genius. I completely do not agree with that statement, right? I have my vertical that I have an experience in, but I also look at you in the same way where I recognize, man, I can't do your job. I actually have functionally no idea how to be a pen tester, right? Like, I don't. You talk about doing these things in a manner that is simply, I will use a quote. I will use a quote from my Navy days where, I'm not going to say who said this, but I was giving a brief to a rather important individual, and I was saying, oh, we're simply doing this. We're processing this data and simply doing this, and as a result, we get this result out. And the person looked at me and said, boy, you keep using that word simply, but I'm lucky if I can turn that thing on in the morning. And I'm not telling the story very well, but the gravity of the situation of this particular person saying that phrase was just kind of like, oh man, we're screwed. Right? But that's how I feel. And I think it's important to note this. It's just like, we may be very good at what we do on both sides of, what it is we're doing within cybersecurity or within software engineering in general, but we both see each other as black box wizards. Right?
Yeah.
And recognizing that is important.
And that was my point. It's like, I see myself in your vertical as an idiot child. In my vertical, I can easily say is like, I know what I'm doing, but yet if I take any aspect of what I'm doing, like reverse engineering, malware analysis, pen testing, and let's go into pen testing, application assessments versus network, then network, Windows networks, Linux networks, integration within cloud for AWS and Azure. And then you go even deeper into any of these things and you go, okay, data laking, infrastructure, and like you go deeper in any one of these things. There's people who dedicate to that vertical who blow me out of the water for any piece of this, like any piece of pen testing. Pen testing is like, my point in saying you have all these different verticals and there are no experts is because going back to the unique snowflake, those unique things that make your knowledge, I'll say unique, gives you a unique perspective on whatever problem you come across.
So
I think,
yeah, I want to drive back to the rant, if you will, the everything's broken forever. This is kind of the reason why everything is broken forever, right? There's this old XKCD comic where it's like, there are 15 standards in order to accomplish X, Y, and Z. I am going to propose a standard that collectively defines all of these things and is the end-all, be-all for these standards. And then the next panel is, there are 16 standards that to say how to accomplish this thing. And this is kind of it, which is, it's not possible to be an expert in everything computer science. It is not possible, because it is like being an expert in pure logic, right? At a certain point, and if you want to get philosophical with it, at a certain point, our understanding of why logic is, like, if you want to get super meta about it, it breaks down. Like, you start getting into, like, is the self... right? Like, not like why do we exist? No, just like, is the self, is self a thing, or is it just a construct in which, like, it gets super like metaphysical, if you will, about it, right?
Well, pull us out of meta and like oh goodness, there's no way to say this statement out just sounding remarkably arrogant or anything like that, but like, it's very similar to being a doctor. It's like saying you're a professional doctor. You know everything of doctoring there is. And it's like, the field's too big. Now, you can make easily a career just being a general practitioner. But even if you go into like radiologist, ophthalmologist, like whatever it is, you can go even within that vertical. There's people who specialize in every little nick and cranny, all the way down to like really, really like protein binding of blah, blah, blah within this specific type of vertical. And I think that exists in cybersecurity too.
So, and this is something that I think is unique to cybersecurity. In other areas of science, they say that science advances one retirement or death at a time, right? Which is to say there's this old guard that believes a certain thing about the realities of whatever science they are studying, mathematics, physics, etc. And once they, amass a following, their followers reinforce what it is that their models are, that they believe. And once they retire, it opens up space for new models to have a following. And that's how these old, when I say old, I mean like centuries or 1,000-year-old sciences, mathematics, physics, calculus, etc. That's how these sciences have tended to progress. What I think people forget when it comes to computer science and computer security, we're like 100 years into this, maximum we're 100 years into this. The reality is like the first real computers and like the first analog computers go back to like the 1800s basically with Charles Babbage. But in terms of digital computers, like we're not even 100 years into the digital computer. Like we didn't really functionally make a real digital computer until like what, the 50s? Not the 50s, maybe it's the 40s or something like that. I don't know the exact date, but that is the time scale in which we're talking about. That's only like 3 retirements, guys. Like,
well, I mean, like,
and girls.
Here's what's so funny about that too, and the whole idea of security didn't really exist. And then you actually go one step beyond this. The whole idea of security in general, like, forget about technical. Like, I think it was like 1905 was the first hacker who was like, it was like Neville. I did a whole video on this. Effectively, him hacking a radio and injecting things into the radio waves. Effectively, it was a new secure transmission. It was like pretty much just an AM frequency, and he tuned into it and then started throwing like the words rat and talking about how the guy was diddling the maid. It was his name will come to me in a little bit, but that was in like 1905, and that was like the first like the scientific hooliganism. By the way, like, what an amazing phrase, scientific hooliganism. Like, I really like aspire to have that be like my title someday.
Man, but that is a really great title. I love that.
But this idea of like, there was just trust. Like when you anything in computers, everything was trusted. And then we built security into it. And you think about like HTTP. Right now, if we put an HTTP website online and tried to like put it as a banking website, you wouldn't be allowed to do it. You'd be laughed off the street because everything's just going over plain text. But when the internet started, when communication started, there was no encryption. There was nothing stopping anyone from just sniffing over the wire and grabbing all the data.
So I want to take a step back, actually. Forget networking, right? Forget networking for a second. Let's just talk about a box that is not connected to the internet. There has been, like, the idea of security has been around for a long time. Within the context of computers, the idea of security has been around longer than the internet, right? Because we had the invention of the password and how do you restrict access. At first there was, computers weren't that complex, so you locked the door instead of just, having a password on the computer. But I've read some of the seminal papers that originally, we're talking like how Unix got designed and the idea of having user accounts on a machine, and not just having user accounts, but also having permissions on files that limit that particular user or that particular group or that. This idea of like file access, having assigned access to a group or a user, goes back to like the 70s, whenever Unix like was starting to come out. But like the seminal paper that defined how this was to be is like from the 80s. And I'm sorry that I can't quote the name of the paper. I could if I did a couple academic searches, but I've read that paper a couple of times, and it's amazing to me that today it is still incredibly accurate as to how things like Linux and Windows work. There's a lot of systems on top that allow for administrators to do more advanced things, but in reality, it points out that like you have data and data needs to be segregated. You have users and users need to have very controlled access to this data. And then you have these actions or intents or whatever you want to call them that need to be able to say that users can have access to being able to do this action, which has access to this data. And you need to have appropriate seclusion amongst all of these things, such that if I, compromise your account, that I don't get access, that if I compromise your account, I can't get access to somebody else's account just because I have access to your account. So I might be able to get access to your files, but I won't be able to get access to their files. So like the idea of security in the context of a computer with that construct before the idea of like binary exploitation really came around as a mainstream thing. That idea has probably been around 35, 40 years, maybe a little bit longer. But that, really putting this into people's perspective, that is 1/2 of one person's lifetime, right? There is somebody alive today that lived 30 years prior to that concept being developed. I know that was a long sentence, but that's how young of a field we are in. And the ultimate goal of this discussion is really, why is everything broken? And why is everything hopelessly broken? Which I know is a really pessimistic statement, but at least in our lifetimes, I don't think we're going to get to the point where that's not the case. And the reason for that is the science is so broad and so young and not well enough understood and not well enough standardized that functionally every IoT piece of equipment on the market it's the wild, wild west of firmware development and is this secure? It's, paths to market. So even if I don't have access to your Windows box, which is totally secure. Like Windows and modern Linux totally is very, very sophisticated and very secure. But if I can get access to your webcam, which now has, is a smart webcam that has the ability to do everything an old computer can do, except with none of the security protocols on it, then who cares?
This is what's so funny. All right. My parents, when I was talking to them one time, they were talking about so my daughter's starting to do science class, and it's amazing because she's getting excited about anything, like baking soda and vinegar is the coolest thing ever. I was talking to my parents. They played with mercury with their bare hands in their science class. This was normal for them. They dipped coins in it. And it's massively carcinogenic. You can't just play with mercury. And they were talking about oh yeah, and they'd pour it a bunch and you'd stick your whole hand in it and you're like, what? How did you think that was a good idea? They smoked on airplanes because smoking was good for your lungs. The mentholated cigarettes were a health thing. This is insane. And I laugh because you laugh at them and you're like, how could you guys ever think that? And I'm wondering within security, within, we'll call it cybersecurity, what things are we doing now where we're going to look back in 5 years, 10 years and go how stupid were these people? That's not how it works. That's not how any of this works.
I don't think you really have to look all that deep, right? We look back at the early 90s where computers had a simple password login, right? And everything was sent over clear text and all of those things. And now you look at I don't mean to hammer on IoT as if it's the problem, but you look at IoT devices and the way people build firmwares and the way people just ship out devices, and I'm not going to say they're putting no thought into it, but because of the resource constraints within these devices, it's just the reality of it, and they got to make business decisions. It's the same situation. It's not that nothing has changed over the course of 40 years. It's just that because the market demands speed, decisions are being made to eschew security in favor of being the first to market with a particular product. And I'm not going to take like any specific product because I don't want to hammer any one group when it's literally the entire market making this issue. Unless they're like serving to like, the government, in which case they have to meet a bunch of standards. But if they're just, if they're just dealing with the average consumer, they don't really have to care.
Well, that's just like my point. I said this during a live stream one time, which was like, if you work at, oh goodness, I was going to say Tom and Jerry. Tom and Ben, what's the ice cream company?
Ben and Jerry's.
Ben and Jerry's. Gosh, all right. Ben and Jerry's. If you work at Ben and Jerry's, your job in the security department is to sell ice cream. Yeah, security and all of that, make sure the website's secure. But like ultimately, the whole goal of the company is to sell ice cream, and your job is to support that. And when they have a new website going up to sell ice cream, and you're the security team, like at the end of the day, they need to sell more ice cream, and that website is going live, and you can check security, and you can put security into the development lifecycle and things like that. But the market is made to put, like we're a capitalist market. We're made to push it out and then fix it later. Windows 3.0 was like one of the best examples of this, and I think they set the standard for all technology. Windows 3.0 was the worst operating system, and I'll pull back in a second. The worst operating system. It's horribly buggy. Tons of things broken, but they pushed it live. Why? Because it was the best of the worst. It was so much better than everything out there. Like nothing even came close to it functionally. And their idea was, if we wait for this thing to be fully formed, fully fixed, fully like non-bug, it will never go out.
You'll never get there. Like if you want absolute security, it's something they teach you in a lot of security classes if you go into a computer science degree, and it is that the more you make something secure, the more we'll just take encryption for example. The more layers of encryption that you add to any given thing, we're just like you have encrypted at rest and encrypted in transit and encrypted while it's being processed and encrypted. Every time you go through these things, you add overhead, which means it's slower. And if it's slower, maybe you can deal with that, and maybe you can't because you're trying to, for example, make a bank transaction in as fast as possible because you want to be able to make a stock transaction before somebody else does, and whatever. And so this is where like philosophically, it's just like, how can you possibly build security in to the level that it is perfectly secure, knowing that it makes everything slower outright, or it hinders your ability to do your job, right? The more access controls I place on you and I reduce it, there's this idea of like minimum access for any given user where, working on a corporate network, for example, I can't have access to being able to copy things in and out from USB. I can't plug random devices into the machine. Basically, like just disable all the USB ports because that is a security, vulnerability because I'm a human being and I might do something stupid like pick up a USB drive from outside and plug it into my corporate network, right? Like so a corporation might just say like, okay, all USB devices are turned off by default. And if you really, really, really need it, then you need to ask for permission, and then we'll give you that permission, and then your liability goes up because, you requested it, and now you have a special permission, which means they have the ability to fire you if anything goes wrong or hold you accountable, right? So like it's all a business decision in this manner, right? And so this is like the more security you add, the harder it is to do your job or to do what you're trying to do. And in some contexts, that's okay. In other contexts, it's incredibly unacceptable because then people just won't use your thing, and that means you can't make a buck, right? And so that's like the fundamental thing that breaks everything, because security, by itself, the idea of security goes against ease of use. Like, wouldn't it just be easier if I could walk up to every computer and just be able to use it without any login or any of those things?
And it would be, and here's the other piece of this is like, regardless of how many layers of security, and I think like things like encryption at rest, encryption during transmission, encryption during processing, the user never experiences. Like those things can be done, and there's overhead like slowness and things like that. But at one point, the user needs to log in. They need to log in with a password. They need to log in with a two-factor. They need to be able to interact with email. But at the end of the day, once they're in, like these are the attacks which I see all the time, which are so successful, is they need to be able to communicate. They do that over email, and that's an accepted form. Like, I think this is one of those things, by the way, we're going to look in 5 years and say, this is insane, that like common email, we always treat as if it comes from this person, it must be coming from that person. Like one of the biggest like attacks that happen all the time in the financial space is like someone in the financial department gets popped, they get their email hacked, they have redirects in there, and they didn't have two-factor put on because there's like a group inbox or any number of things. And then they hijack the email and they send an email over to someone else in another department and said, hey, this wire needs to go out. Here's the information. And then the wire just gets sent. And this is one of those hard vulnerabilities because it's not fixed with a technical, like, here's the hands-on keyboard, here's how you fix it, here's like the secret code you have to put in. It's like a security awareness thing, which are like the things which are just frustrating because you can't fix them to a certain extent.
Yeah, and you can, an old Navy saying is, you can't stop stupid, but you can slow it down. Right, so you can put any system you want in place to try and solve that issue, but at a certain point, it's going to break your ability to do work, so you have to make compromises, and those compromises are what make it not impossible to do quote-unquote stupid things or to be taken advantage of. That's really what's going on. People taking advantage of that system, but that's the reality is you're just slowing that down, which is important. Like, I don't want any viewer to get the idea that we're just saying everything's hopeless and you shouldn't even bother and anything like that. It's just kind of a lamenting of 15 years in this industry and seeing the same stuff that I have seen for 15 years continue to go on. And it's this, I was just telling somebody tonight, this idea of like, I'm kind of burning out in this sense where like, it makes me want to delete computers and return to monkey, right? Like I have started a farm with my best friend in the world where we grow plum trees, and I'm seriously looking at like, how big do we need to make the farm for me to stop working in cybersecurity? Because that sounds like, even if I want to go dig in the dirt for the rest of my life and forget computers exist. Right, that actually sounds kind of wonderful. I'm not gonna lie. It certainly sounds it's definitely simpler. Maybe sort of like organic chemistry and understanding how to grow things. Not easy. Definitely not easy.
As time goes on, I expect that like attacks and we'll say like the major hacks are going to be like, I came into the house, I hooked up the keyboard, I bounced a laser off the moon, off like some mirror, and hit into a window and felt the vibrations and measured those and turned those into the audio signal, which I get to declare, like I get to decipher what they're saying inside. Like, no, like every major attack comes down to like the simplest vulnerability. It's still SQL injection. It's still a guessed password, a missed two-factor. Like, when you go down to like even like these crazy sophisticated vulnerabilities, you get into like we'll call like the ones that shake the world. They're at the end of the day, it's one line of code. Log4j, arguably the biggest vulnerability that has ever happened, the most prevalent. Maybe it didn't take over like a missile system or something like that.
Yeah.
But what it did do is it affected everything, but it was injection. It was a simple injection. Heck, even a feature which any kid could duplicate in their Minecraft server.
Right. And this is kind of the point. And like I'm lamenting this a little bit too much, but it's even with all of the advances in things like memory safe languages, Go, Rust, things like that. Those advances are great and they're really important, and they do solve entire classes of bugs, but they solve classes of bugs that the number of people in the world that can exploit them is incredibly small. Incredibly small. But if you have a logic bug like log4j, a sanitization bug, Rust doesn't solve that. Go doesn't solve that. And the problem is you're using like some form of regular expression. Like when you get down to something like sanitization stuff, like it's a solved problem. And so if you're rolling your own, you're doing it wrong and you're bad and you should feel bad. But at the end of the day, people are going to roll their own and they're going to get it wrong and they should feel bad. Like that's the reality of it. And you're going to hit this. And even in this third-party package, which everyone in the world basically used, you would think someone would find it. Nope. And that's what happens. And that's why, like, it's like what is the phrase from the Street Fighter, the movie, where it's like, for you, when log4j hit, it was the most important day of your life. For me, it was Tuesday, right? Like, that's how I felt when it hit. You just look at it and you go like, yeah, okay, whatever.
Yeah, another thing is everything is broken vulnerability. And what was interesting about that is like it came out later that there was really great protections people could have in place, like having good egress filtering outside their network would have stopped the vulnerability, any exploit code from reaching out over LDAP and pulling down the code. Because why are you reaching out? Why does your network allow you to reach over the internet for LDAP? Like, there's not really many purposes I can think of that need to do that.
At least
I agree.
At least not raw, right? Like that stuff should be tunneled.
Easily.
Right. Like if you have to do LDAP over the internet, you should probably have a VPN is somewhere in that process. Like the
and I think that's what's so weird with this is like there are like fundamental things, like as you said, like you can do the address randomization, but like this is where technology is driving it. It's constantly changing. You look at like the best security tools to like find vulnerabilities within applications, like the best of the best DAST tools, which are like the dynamic application scanning tools. Like fundamentally, they're really dumb how they work. Like they go through and they find all the parameters, and then for every parameter, it's going to inject like alert one, like JavaScript and things like that. Can I find cross-site scripting? But here's the thing: is like they're really good at finding SQL injection and cross-site scripting. You know what they're terrible at finding, like abysmal at finding? All authorization findings, like which are just logic issues. Like can user A access user B's data? Can I escalate from low privileged user A to high privileged user A? Like tools have almost no way to do that. They can do really dumb things like I'm going to try and hit /admin and then see if the low privileged user can access that and get a 200 back. But ultimately, our tools are just really dumb in how they work. They're so practical, like static code analysis. It's just like redjacks.
I'm not going to say that I'm an expert in these areas. I'm more of an expert in, virtualization. So that would be the dynamic tool, right? We're actually going to run the software. I'm not going to say that I'm a static expert, but had to go through a number of classes where we were trying to do validation of programs, and they teach you pretty early on, and it's this idea of theorem solving, where basically you have a program and you're trying to prove that given some input that program will halt, or that given some range of input or some symbolic input, if you will, that represents everything, that you can reach some state that is a good or a bad state or whatever. You're trying to reason, you're trying to treat the program as a mathematical equation, and then you're querying some set of, you're basically querying that mathematical equation for, given some symbolic input, is it possible to reach this state, right? And they teach you pretty early on in those classes that if your system isn't well constrained, you're going to run into a state explosion problem, right? So if your system is well constrained and you can prove things, what is the phrase? I'm going to embarrass myself, but it's basically like if you can prove the base case is true and you can prove the next step is true, then logically every other step should follow. But that is limited to when you're dealing with parsing problems for the most part. If you're dealing with complex programs where mutation can occur, aka I'm accessing memory and I'm changing memory, you hit this point where you hit a state explosion problem where you can branch off into crazy places and just end up in like an infinite loop and not really be able to detect that you're in an infinite loop. Like that loop could eventually terminate and end up in a good state or a bad state, and you could detect that. But because the potential state space is so large, you can't actually prove that you'll get there before your computer, before the heat death of the universe, right? And I know I just like took a really long way to get to where I'm going. But the idea is that static analysis tool is exactly what you just described, where if you need to get into, I'm giving this thing data and now I want to reason about that data, just doing it statically gets to be very, very difficult to find logic bugs. And that's where dynamic analysis comes in, where you're trying to test the program on the boundaries, where you're saying that like I, a human, have dictated the boundaries of some input where I know something about the program. So if I can define, here's my upper boundary, here's my lower boundary, and maybe here's all of the places that I can think of where this might break, then if I test those boundaries and show that it doesn't break, then I should be good. The problem with that is that you have to actually understand what the actual boundaries are. And that's where fuzzing comes in, where we make the assessment that most humans don't really understand the boundaries of their programs well enough to write good enough tests. So we're just going to throw garbage at this thing and see if it breaks. And that's the disconnect between a human being thinking they understand what their program does, and what the program actually does. Wow,
which you defined as like that.
Go ahead.
You've defined that that's what a vulnerability is. It's when the expectation doesn't meet the reality.
Yes,
and
so
I think you even said it better.
Where I'm going here with this here is that like static analysis, you have the state explosion problem, and dynamic analysis, you have this problem where you can't test at literally every single input. Here's the thing: they're the same problem. Right. They're the same problem. You're just approaching it from I have a concrete execution, or I have a static model of my program, a mathematical model of my program. But it's the same thing. That's what computer science courses teach you, is that that problem is the same problem. You're just attacking it from a different perspective. And if you can try and reason about what the actual program is and understand, like, is this problem, something that has a polynomial number of potential inputs, and therefore I can test every single input within, a year. We'll just say a year because that's reasonable-ish. If I can test every single input over the course of a year, then I can do it, and I can 100% prove that I know the potential output from this program for every possible input. But the reality is programs are so complex that there's no possible way for you to do that. So you have to try and define boundaries, right? And that's why everything is so vulnerable and so hopelessly broken, as I put it, is because software is functionally untestable to the extent that we need it to be able to prove these things. Unless you can build software from the ground up in a quote-unquote perfectly secure manner such that you can mathematically prove without having to test every single input and output that your input will have the desired effect.
You would have to design whatever you're designing in a vacuum.
Yep.
No third parties, no interconnectivity. Like something I see really frequently is like the moment, like Say it's an application which allows you to order ice cream, something like that. Well, that has to tie into something like Salesforce or your CRM or an email database or anything like that. So I get to input my username. Let's just say my name and address, and that goes into Salesforce. Well, another system has to create an invoice for that user, and it pulls that data from Salesforce into it. I need to trust not only my data, but anywhere that data goes, in anything I pull from any data. And this is like the fundamental problem with like third-party packages is I need to trust what I put into them and what comes out of them in every database that I go in and go out. And then you finally figure out all of that stuff. Let's just say like you finally go, that's great. My first name field and my last name field, I have fully defined. And I've even massively restricted it just because I don't trust these systems. And I'm going to just do the name like it's just alpha. It's just alpha. Like all I need is all alpha characters allowed. And then some jerk like O'Brien, because the Irish have messed this up, because then you need an apostrophe. Yeah. And then you get Elon Musk, who names their kid with some sort of silly number system. And now I'm the jerk who doesn't let them put numbers in the name field. And this problem just gets blown out because then you have business requirements because we have to let Irish people order ice cream. So we have to allow an apostrophe in the last name, which completely hoses a bunch of your security your security pieces.
Right. And this kind of gets to, if you want to get more complicated with it, right? We like to think of our program as operating in a vacuum. Forget third-party packages. Your program has to run on an operating system. So you have to make assumptions about the system calls that you're making. You have to make assumptions about the underlying software. So unless you're designing the entire operating system, and it gets worse, right? Like what you've just described is a system of systems. You have one system that talks to another system, and then maybe part of that system is a human system. It doesn't matter. You can still think of it as systems. You have many systems working in concert with each other to accomplish a task. So if I want to assess a system of systems, each individual component of that system could be individually secure. But once you put two things together with functionality and you give control of those two things to one user, this thing could have perfect access to what it actually requires, to accomplish its job. And this thing could also have perfect access to what it actually requires, but they could have two different sets of permission. But because I'm the person who's in control of those two things, I now have access to two sets of data and I can combine them and pass data between them, right? And so this is kind of one of the problems that they're discovering with stuff like Android and Apple is if I load a bunch of applications onto my phone, well, if like one of them provides permissions to the camera and the other one provides permissions to the microphone, and I'm able to control both of them, then I control both the microphone and the camera, and I can build something on top of that. So it's like a set of chaining exploits. And so you could have a perfectly secure system, but because you've slapped a bunch of stuff together, you get what's called emergent properties. And as a result of that, even the application developers can't really assess how well their system or their software is going to be secure on any given platform because of the nature of whatever else the user decides to load onto their platform. It's kind of a nightmare, and like it's something that keeps me up at night, and it's why like over time, and if all you care about, if you're watching this and all you care about is like how do I make myself more secure, define a minimum set of applications that you need to get on with your life and never download another app. Like occasionally, like if you want to download a video game, fine. Download the video game, play the video game. When you're done with it, get rid of it, right? Like do not keep these things around because you do not know what the potential vulnerabilities in that thing are. That's what I will say. Like on my desktop, like I have 2 video games, a browser, and that's it. Like maybe I have Discord. Like I have a couple of chat programs, a browser, a couple of video games, and that's it. And that's like I don't have a ton of fanciful stuff. You might think I need that as a developer, but I have that entirely on a separate box And I don't use that for my personal stuff. Keep those things entirely segregated.
I'm laughing at my testing system because it's like, okay, I have Safari, Firefox, Chrome, Brave. Like, you just have every... It doesn't matter what the browser is. If there's a vulnerability for one of them, I will have it on all of them. Even if there's automated systems built to catch the vulnerability. Let's use like the example you gave. Use very little software. You have some sort of protection. Let's call it an antivirus or endpoint protection. Like, I can use an enterprise example that like we've come across, where what you can do is they had CrowdStrike, which was great. And we needed to try and circumvent some of the security. Well, we had a very hard time really getting around their team because it was really good. So an opportunity we had was like, cool, we'll just create so much noise on the network and so many events happening that they can't really respond to them all. So when we do create the domain admin account type of thing, it might be missed. Or why create one domain admin when you can create 15 domain admins? And then actually all you're doing is changing the password for one of the ones they currently have, and maybe they're missed a password change with all the other noise. And this is the thing, is like, even if you have a great system, you have the protections on top of it, there's still ways, like, as you say, the more things you put on, the more complex it gets, and then someone has to respond to any one of those things.
Yep. And I mean, I think we're digging deeper into this hole of like trying to justify our statement from the beginning as to why everything is quote unquote so hopelessly broken. So I keep using that phrase, so hopelessly broken, because there was this DEF CON competition that was, so hopelessly broken, as in SOHO, small office, home office routers. And it was used to demonstrate that the average consumer router was so broken that you could get into it any number of ways. And it was really effective. I think they're still running at DEF CON. I don't remember seeing them the last one, but it was a regular occurrence for a number of years. And it was really effective at what they did. So yeah, I keep using that statement kind of intentionally. But yeah, I think we're getting down this route of just saying, like, everything's so hopelessly broken, here, let me justify it. But maybe we should leave off with a sense of, like, is there a reason to be hopeful? Is there a reason to keep on keeping on within the realm of cybersecurity? Like, obviously, I'm not quitting my day job. I'm going to stick right where I'm at, doing what I do, trying to provide people a testing infrastructure that allows them to try and make things more secure and to try and, if you will, spread the good word about dynamic testing and fuzzing from the get-go instead of slapping it on the end and calling it good.
I think it would be funny just to end the stream, be like, everything is hopelessly broken. It's all done. Like, the end. See ya. Bye. Mic drop. And I think it's like, in one case, you're like, okay, cool. Like, oh, we'll always have a job. And I hear people say that all the time. They're like, oh, you always have a job in cybersecurity because everything's always broken. And Log4j, at least that means job security. Like, I hear people say this, but like, the honest truth is, this is what I love. Like, you say you want to go off and do a farm at one point. I freaking love information security. Like, I legitimately love every aspect of it, because it doesn't matter. Like, if I get sick of pen testing or security, like, cool, I'll go learn to do more development, or I'll go learn and do incident response, or I'll go learn and maybe learn like emulation or something like that from you. Teach me, senpai. But I think that's what I love about it, though. It is so hopelessly broken, but there's so much changing all the time. Like, we talk about DAS tools, like, there's so much improvement that can happen. So I guess, like, I get hopeful off all this stuff because it's so broken. There's so many areas to improve, to excel, to learn something new. So again, I don't know, like, maybe that's like weirdly hopeful, like weirdly optimistic. Like, everything is on fire, but that's great because I am a fireman and I get to figure it out. Like, and hopefully I won't like die in a fire. That's horrible.
Yeah, I mean, I guess the thing I would say is that I do enjoy, like, I'm one of those strange people that I sit down and I can pull up the Intel Software Developers Manual, which I have open right now on one of my other screens, and Let me tell you how many. This manual is 4,830 pages long as of December 2021. Right, it gets longer with time, and I have probably read, I don't know, a couple hundred pages worth. And someday I hope to have read the entire manual, like the entirety of the manual, so I can understand the entire history of the x86 architecture and how Intel has chosen to bastardize it, and to understand all the intricacies of it and why we are in the boondoggle of where we are, and more importantly, why ARM is making a lot of the same decisions that Intel made over those many years and AMD made over those many years in creating extensions, and why we get into this situation of architectures seemingly starting as relatively simplistic and eventually growing into behemoth monstrosities that have all kinds of problems, right? So like that's the hacker that I am. Like I want to read these systems and understand them and understand how to use them and understand how to use the actual chipset that's in front of me instead of just launching a browser. And it makes me hopeful in the sense that I see the chip manufacturers building more tools into the hardware that enables software developers to do smarter assessments of their software. Now, like, what do I mean by that? I mean, like, we'll just take Intel. Intel has on their chips this thing called Intel PT, processor trace, that allows you to do code coverage utilizing this like complex packet format, and I don't want to go into the details of it, but basically it's a faculty on the chip that allows you to do some level of tracing of a piece of execution of your code, and it's really efficient, and it's really good at not just being able to say what did your program actually do, but how long did it take to do it. So you can use it from two perspectives. You can use it to try and make your software faster and to profile your software, but you can also use it in order to understand, like, where did I go? How did I end up into this bad state? Or give me that feedback so that I can build a smarter fuzzer to try and fuzz these things. And if you go look at how people have integrated Intel PT into fuzzing platforms, it's quite amazing. And I have to imagine that the folks at Intel actually put some thought into, well, how are security researchers going to use this? Because there's a lot of features in there that are useful, I think, in part mostly to those people as opposed to just the performance seeking people. So it makes me hopeful in the sense that architecture developers are making extensions not just for like encryption at rest and encryption during processing and all of those things that you would expect, but also advancements that enable people like us to do cooler vulnerability research or research.
I think there's especially like beyond that. You said that talking about creating profiles and things like that. I think with the increase of like awareness and like what is the expectation, I can't wait for more of, we'll call it the behavioral analysis. Like we call it, like when antivirus started and things like that, we were just like signature based. Like does it match a signature we have on file for malware? And then we enter like heuristics, like what is the expectation? Is there an outlier? I can't wait till there's like behavioral things. And this is like the level that red teams have accomplished, where like there was I forgot who it was. It was Grim. It wasn't Grim Security Research. It was one of them. But effectively, like what they talked about was like this growth of living on the land exploits, like things that work off of native PowerShell and exploits on Windows systems, which use normal things. And it's interesting that they don't even make them automated, where sophisticated attacks will do like really interesting things. Like, did you know, by the way, you can use excel.exe to download files on the internet, like right from your command line? It's hilarious to me. You just go excel.exe and then the file you want to download, and it will download it.
Dude, there's an entire programming language within Excel. Like, people don't really realize how powerful Excel really is. But yeah, you can download stuff from the internet, you can process it, you can write an entire program in there, and as far as I'm aware, it's Turing complete, which means you can do literally everything.
Living off the land exploiting, where you go, what would a normal user do? Well, they would go to their email, they would download an attachment, they would put it on their desktop, they would run that, and they're like, okay, if we want to make sure we're not detected by the blue team, we need to follow a normal user execution in order for it to evade detection. And I think that's what gets me excited with some of, as we get better at processing, as we get better at the heuristics, as we get better at like behavioral analysis and the processing power that's really needed, I want to call it the machine learning artificial intelligence, but that just sounds really goofy. And I've always laughed at that when it comes into the security realm. But when we get to the point like where we can map those things and then easily see deviations from that, that's where I think security will go a step beyond.
You're getting the hamsters are spinning in their wheels now. I don't think it's going to be as easy. It's definitely not going to be easy. I don't think that it's going to be as simple as what you have described, right? Because we can profile what the average user does and all of those things and try to fit in within what that user is trying to do. What I think is going to emerge out of what you're suggesting is these platforms that detect more about what's the timing of these things, and does it look too stiff? Does it, is there any form of pattern? And this is the eternal rat race, right? Because once you have a model of how you're going to run these exercises, and as soon as somebody gets a whiff of how you're running those exercises, you can start to train something to find it. But then once you get a whiff of that thing that's detecting you, you start to change your model, and then the scales start to tip back and forth. This is the eternal rat race of the security realm. And it's actually, I don't mean to go negative again, it's actually one of the things that makes me kind of exhausted working in this realm is, it's like, it just feels like that's what we're in, this constant cycle. And if we're not trying to make our systems better, like fundamentally better, by employing things like Rust, employing things like Go, if we're not trying to do those things, then why do we even bother to try and build these antivirus systems? Because like you're not going to catch the really dedicated hackers.
Well, I mean, that comes out with like the ransomware. Like we start going, okay, let's detect all the files in the system. Let's take a signature of them. How many signatures are changing per second? At this point, let's flag it. And then malware's gotten more sophisticated with it. And you're right, there is a back and forth on it. And I do think it is, we'll call it the pendulum shifts back and forth. How well can we secure the systems? How long can we not? And Go, Rust, like moving towards these things helps. But I don't know if there's ever going to be a time where it's not that back and forth. And I don't know if that's just like a downer, but I think that is what it is.
I said it early on. I don't think it'll happen in our lifetimes. And the reason why I say that is because the science of this is just too young. There are fundamental truths to computer science, right? And we talk about the halting problem, and it's this big like hand wavy problem where it's just like, well, that maps to the halting problem. What does that really mean? What that means is that, like detection on a network maps to the halting problem. So anytime that you think that you could have an oracle to detect an attack happening, I could write an attack that proves your attack wrong. Or your detection system wrong. That's what we mean that it maps to the halting problem. Because if you say that you have the silver bullet, what you have just tried to prove is that 0 equals 1. There's no such thing.
Yeah.
And there is an actual proof out there, a scientific proof that maps detection to the halting problem. And over time, like this is the thing that people really need to understand, is that over time, people are mapping more problems within the security space back to this maps to NP hard, or this maps back to, the halting problem. So what they do to get around those issues, because that doesn't mean it's hopeless, what they do to get around those issues is they go back to, okay, let's look at the system that we have defined overall, and understand how to redefine that system such that our constraints are placed in a way that we don't run into this particular problem ever again. And that's why systems like Rust and Go exist, is because people have said, oh, we can't solve for this in this system. Let's redefine the system. Now we don't have that problem. Oh, there's other problems that we have. You still have logic bugs. You still have, the log4js of the world that aren't necessarily going to be a buffer overflow or memory unsafety or any of those things.
I don't know where to end this.
Neither
and I'll
do
just
I.
be completely honest. I don't know if there's any way to end this on a happy note. There's not a pot of gold at the end of this rainbow.
There isn't. Like, what we're really talking about in some sense is like why there are a number of people in my life that have burnt out of this industry and have more or less left this industry, or worse, have stayed in the industry and are just good with it. Like, everything's broken. I'll do the patches here and there, but I'm not really going to try and make the system any better. I'm just here to collect a paycheck. I don't know if that's worse because they're still engaging and they're still trying to save people from the badness, if you will. But they're two different problems. And to me, like, fundamentally, this all tracks down to the fact that, like, security is so hard that it might not be solvable. And as people map more problems back to those fundamental truths of mathematics and computer science, are we ever going to get to a state where the world is, at least in a computer sense, secure? I don't believe so, personally.
I think a full topic on like burnout and things like that would be interesting. I think like one of the things that actually like we'll say like turns me on to the subject, is awkward as that sounds, is like it's a reason why when I play video games, I enjoy PvP more than PvE, because I love the fact that there's someone getting upset on the other end of the line. I don't know why. I know that's horrible, but I think that's part of the reasons I love pen testing, because I know that it's like, it does feel like it's one of those things which have made me almost burn out in the past, because I have to like, I've always been on the consultant side. So like in some ways, like every victory I have where I find an insecure piece of software, it's a screw up on their end. Now that's a very like a junior way of thinking, because oftentimes it's not their fault. There's too much to know on the security side. They're just trying to sell ice cream. So like there's a whole discussion to be had there. But I think that's one of the things which gets me excited with a lot of like the pen testing side or CTFs or anything, because like you have some form of victory you can have. I think the part which like starts burning me out is when you've tested the same app so many times. You've tested a network which is relatively secure. Like networks have gotten really, really good. Applications have gotten really good. And you just bash your face against the keyboard, and despite remarkable success, you feel like you're failing. Despite going through the methodologies, doing the best testing you've ever done, you don't find anything. And while the client loves it because you didn't break their application, you feel like a failure. And I feel that that's going to be the definition of burnout for me, which is despite remarkable success, you feel like you're failing.
That's such an amazing dichotomy, I have to say. Because for me, I don't care about any of that. I care about the process of building something to analyze something. I don't care about how it gets used. That's somebody else's problem. They want to find a bug with it? Fine. They want to secure their software with it? Fine. All I want to know is what data they want and how to provide it in a performant and useful manner. And like the process of design and the process of understanding the problem and solving the problem, the win for me is, and like sometimes what my form of failure is when I collect all of that data and I come to the conclusion that I can't solve it, or that I'm not smart enough to solve it, or that the problem is so big that I would need a $3 million budget to solve it, or just to even start solving it. And that becomes like, it's functionally a form of failure where I have to look at somebody and go, yeah, we can't do that. Or you can't do that, right?
And I think this is like what drives you. And this is a whole nother conversation, but I think this is where we end, which is things are broken. But you have to find the things that, like, what drives you in this industry to continue solving problems, because that is what makes us hackers. I love the term because it is that curiosity of, I have a problem, how do I solve it through any means necessary? Like, through a relentless pursuit of bashing your face against the keyboard, I am going to figure this out. And I think if you get to this idea of, like, we'll say it like when you first start, the idea is get going. Like, just get going. Like, it doesn't matter how. Just start moving in the direction of solving the problem. You start hacking, great. Get going. Go set up a try hack me. Go set up blah, blah, blah. Go grab the Intel book and read and have some form of get going. I think the next one is then get good. I want to learn my methodologies. I want to learn the tactics. I want to get better at my craft. And then eventually I think you move on to the get smart. I want to get smart with my tactics, get smart with my methodologies, get smart with my how I present information, and how do I continue to better myself. And I know this was a really long conversation, but ultimately I think at the core of it is there are what happens when the unsolvable problem meets the unstoppable hacker, and that's where it is. It's like, what happens when those two things collide?
Faces rolling across keyboards endlessly is is where it is. No, I think this is it's. And I'll end on this. Like, what we've just described is two different perspectives of the definition of hacker according to the RFC, right? Which is a person who takes delight in having an intimate understanding of the internal workings of a system, computers, and computer networks in particular. And you describe it from the perspective of the hacker who is using it to break into stuff and finding failure because despite having the intimate understanding of all of these things, just there not being anything there to find. And I find the burnout or the failure in, despite having an understanding of my particular vertical and getting all the information in, I am missing some piece of information or time, or missing the time I need in order to process and actually solve it, because there are other, pressing issues. Same thing, in my opinion.
I think with that, thanks for watching, and hack on.